Hello. It is E cathode minus E anode. This is the formula we all know to calculate. But in this case, which one is the anode, which one is the cathode is not given. We are given the value for zinc, which is as minus 0.76 volt, and for copper it is given as plus 0.34 volt. So how to find out which one is the cathode and which one is the anode? We know that, or you should know, make it as a point. You should know the standard reduction potential will be high for cathode and it will be lower for the anode. So in these values we can see that out of minus 0.76 volt and plus 0.34 volt, which one is having a higher standard reduction potential? Copper is having a higher standard reduction potential. So the copper will be our cathode and the one which is having a lower reduction potential will be our anode. Thus we can calculate E0 cell is equal to plus 0.34 volt, or you can simply write 0.34 volt minus of 0.676 volt. So you will be getting 0.34 volt plus 0.76, that is 1.1 volt. So our answer is 1.1 volt. Moving on to our next question. The next question is, a cell reaction has been given and we are asked to represent the cell reaction, or we are asked to give the cell representation. It is very easy. You can see that in this reaction, what is happening? Zinc is undergoing oxidation. No, undergoing oxidation means 2 electron, and copper 2 plus is accepting these 2 electrons and it is undergoing what? It is undergoing reduction. So we know that in anode what takes place? Oxidation takes place, and in cathode what takes place? In cathode reduction takes place. Now how to represent the cell reaction? You remember, in the left side we represent the anode and in the right hand side we represent the cathode, and in between there will be a salt bridge. So we can remember it as ASC. What is ASC? Anode, salt bridge and cathode. So which is the anode here? Zinc is the anode. So how can we represent? Zinc is undergoing oxidation. There is a salt bridge. Copper is undergoing reduction. So the cell representation is zinc by Zn2 plus, salt bridge Cu2 plus Cu, or we can remember it as ASC. What is ASC? Anode, salt bridge and cathode. So based on this type, let's move on to our next question. A cell reaction has been given and the value for each electrode potential is given. Half cell electrode potentials are given. So the cell reaction is, what is our cell reaction? Magnesium by Mg2 plus, salt bridge Ag plus by Ag. How to find out the EMF for E0 cell? It is standard reduction potential. We can calculate as, we know the formula. What is? E cathode minus E anode. Based on the previous question, you can see that which one is the anode? This one is anode, salt bridge, cathode. You can remember this way. So our anode is what? Magnesium, which has got a value of minus 2.37, and our cathode is, which one is our cathode? Silver is our cathode. So we can write it as, directly we can substitute the value. So the value for cathode or silver is 0.80 minus of minus 2.37. or the answer we will get is 0.80 minus minus plus 2.37, that is equal to 3.17 volt. So our answer will be 3.17 volt. Next, moving on to our next question, you can see that here it has been given the standard reduction potential at temperature 298 Kelvin for the following half reactions are zinc, chromium, this is standard hydrogen electrode, and iron. This the standard E0 value has been given. Now our question is, which is the strongest reducing agent? Reducing agent means what? One which undergoes what? Which undergoes oxidation. Again we know that in a cell, which one undergoes oxidation, or at which electrode oxidation takes place? At anode oxidation takes place. Now at anode, what we have studied? The standard reduction potential is low. We have already discussed in a question, no? The standard reduction potential is lower in the case of anode. So out of these four options, you just have a look where the standard reduction potential is the lower one. You can see here it is positive, that means it is higher. Here it is 0. Here it is minus 0.74, and in this case, in the case of zinc, it is 0.762. So if you are given four options, zinc, chromium, hydrogen and iron, the one which is having the strongest, or the one which is the strongest reducing agent will be, just consider all these factors and tell me which one is having the lower value. Yes, you are right. Which one is having the lower value? Zinc is having the lower value. So the standard reduction potential is lower in the case of zinc. So which one will be the strongest reducing agent? Zinc will be the strongest reducing agent. Just go back to the first question that we have done, where we had decided which one is the cathode and which one is the anode based on the standard reduction potential. So the one which is having higher will be the cathode. Similarly, in this problem, the one strongest reducing agent is one where which one undergoes oxidation, that is the anode, that is the standard reduction potential is lower, and that is our zinc. Let us consider the next question. The electrode potential for standard electrode potential for A, B and C are given. You can see the standard reduction potential for A is given as what is plus 0.5 volt. The standard reduction for B is given as minus 3.0 volt, and that for C is given as minus 1.8 volt. Now our question is the reducing power of the metal. What do you mean by reducing power? That means they are reducing the other, that is they are undergoing oxidation. So we know that when we say reducing agent, that means the one which undergoes oxidation. Oxidation takes place at where? Oxidation in a cell, oxidation takes place at anode. So the standard reduction potential will be what? It will be lower. Similarly, when we say that oxidizing agent, that means what? It is undergoing reduction. Oxidizing agent means it is undergoing reduction. Reduction takes place at where? It takes place at cathode, and the standard reduction potential will be high. Now in this question, our question is the reducing power of the metals are. We have to write the order. So the one which is the highest reducing is one which is having the lowest standard reduction potential. So out of A, B and C, you can see the lowest standard reduction potential is for which one? It is for B. So we can write the order as B is the having the reducing power of metals are in the order of B, then followed by C, then followed by A. Just consider these 2 points. The standard reduction potential, the reducing agent, which is also one which undergoes oxidation, and these 2 points, and you can solve this one. So, okay, based on that, do a practice question. The electrode potential for certain metals are given. Potassium minus 2.93, silver 0.80, Hg 0.79, Mg minus 2.37, chromium minus 0.74. 7 volt, sorry, minus 0.7 volt. Arrange them in the increasing order of the reducing power. We have already discussed it in our previous question. So you try to solve this. How you have to arrange? You have to arrange in them the increasing order of reducing power. Hope these questions are easy. Try to do maximum questions on electrode potential because they are important for your exams. Thank you. Hope it's clear.